All right. So we're going to do a bit of a recap to begin the lesson, and then we'll have a look at F and make a start on some of the later parts in F. So what I've got up here, I've just drawn up a few questions from 3D and 3E that we did last lesson. So I know 3D, we found it challenging at first, but we sort of, I think, grasped it in the end. So we'll recap 3D, and then we moved on to sign diagrams. I think most of us were pretty happy with the graph ones. And then when it came to the algebraic approach, that's maybe where we need to dedicate our efforts a little bit, and I'll talk specifically about that. That's how we'll start the lesson. So I'll just get you guys to have a watch while I go through it. And then we've got an exercise that we'll work through for F that we'll probably do individually. Okay, so firstly for composite functions, I have two functions here. We have one function of x, which is 4x take 1, and the other, which is 3 take away 2x. So we know, right, if we're finding f of 1, what we're doing is we're going to put the number 1 everywhere there's an x, right? We're putting that number 1 into the function. So if we're finding f of g of x, we're putting the whole function g of x into f of x, right? So we would have 4 multiplied by 3 take 2x. We're putting that whole g of x function right there, and then we have that minus 1 hanging out the side there. Okay, so that's the substitution. I think that's probably the challenging part, Lincoln. And then what we have to do is expand it and then collect like terms. So to expand, we're just going to multiply the 4 through. That's going to give us 12. And then take away 8x, take away 1. And then 12 take 1 collects to 11. Okay, so that's the first one, f of g of x. We've put the g of x function into the f of x function. Now we've got g of f of x. Now we're going to put the f of x function into g of x everywhere there's an x. So this is going to come here. All right, so that's going to be 3 take away 2 lots of 4x take 1. All right, the whole function f of x is going right there. Now we have to have brackets because it's 2 multiplied by the whole thing. We'll then expand this bracket here, so I'm going to have minus 2 multiply both of those. That's going to give us minus 8x and plus 2. Minus 2 times minus 1 plus 2. And this will collect to 5 take away 8x. Very good. Okay, composite functions, everyone feeling okay with it? All right, so there might be some later parts that people want to ask about, but that's the basic skill that we need. Okay, next let's move on then to sign diagrams. And we know with sign diagrams, all it is an axis, a horizontal axis, and we're plotting on this axis the roots, the x-intercepts, and the zeros. Okay, we use those words interchangeably. They are when the y value is 0. Now, I had a good marker, I'm not sure where I placed it. I'll go with this one. So the roots are where the function crosses the axes. So we have a root at minus 3, we have a root at minus 1, and we have a root at 2. We also have a vertical asymptote at 0. Now an asymptote is generally denoted by a dotted line, all right? But we also illustrate it by these arrows that are going down forever and never touching. They're continuing in that direction. All we're doing with the sign diagram is saying to the left of minus 3, it's below the x-axis. It's negative. In between those 2 points, it's above, it's positive. Okay. We need the asymptote. The asymptote is at y is 0, x is 0. There's the asymptote. Now, in between minus 1 and the asymptote, it's negative. In between the asymptote and the root, it's negative. And then after that root, it is positive. So that's how we draw the sign diagram from a graph. I think that was a pretty okay skill that we started with. But then we get a little bit more complex where we have a function and we're asked to draw the sign diagram from a function. Now what we can do is use our calculator to support us. What I do want to point out though is that we should have a little bit of awareness of how to find the roots and asymptotes from it, particularly if we're looking at doing Year 12 methods. Now for this type of function, we have stuff at the top and stuff at the bottom. We did this in exercise 1D. It's called a reciprocal function, right? We have things at the top, things at the bottom. So if y is a on b, where we have function at the top, function at the bottom, it's going to equal 0. Its roots occur, its x-intercepts occur when the top is 0 and it's undefined. We have an asymptote when the denominator is 0. So we can write that here, x-intercepts when the top, which is x take 2, is 0. Solve x is 2. That's when the x-intercept occurs. And then the asymptote, undefined, or it has an asymptote when the denominator is 0. And so we get x is minus 3. And so that means for our axes, we already have the important points on it. We have an asymptote at minus 3, and we have a root at positive 2. Okay? And then all we're left with to do is to put in where's it positive and where's it negative. Now I did show you an algebraic approach, but I am going to say we can use our calculator. So let's pull our calculators out and we're going to graph that function. So I'll go to my calculator here. Just to point out really how we can use our calculator to support us. So from main menu, we'll go to the graph mode, and we're going to graph the function x take 2 on top of x plus 3. Now maybe we're familiar, this button here is a fraction button. So if you press that, it brings up a fraction for you. So we have x take 2 at the top and x plus 3 at the bottom. And before we graph it, let's all set our V window to make sure we have the same V window. We'll press Shift, V window, and just make sure it's set to standard from minus 10 to 10. This will allow us to see those roots that we already have there. Sorry, I've got a big Y. Let's just change it. There we go. Okay. Now what we'll do is we'll go back to our sign diagram, and we can see to the left of the asymptote, all right, here's the asymptote here, right? This is the asymptote. To the left of the asymptote, the function is positive. So we'll put our big plus there. In between the asymptote and the root, the function is negative. And after the root, the function is positive. Okay, very good. All right. That's a recap of what we've been doing, but now I'm going to take you through what we're doing today. So we turn to 3F in our notes books. Transformations. Now this lesson is going to be a little bit different insofar as it's a self-directed investigation, so we'll do it individually. Okay, we're going to try and perform this investigation on our laptops. So if you haven't got them, you'll be able to go get them in a moment. Looks like most people sort of have them, which is great. So let's have a look at what the investigation tells us to do, and I'll just take you through the first few steps to get you started. All right, so it says go to Desmos. So we won't pull our laptops out yet, just watch me. Desmos.com. So when you go to Desmos, I'll just leave this page. Desmos is online graphing software. And it's a good way to draw graphs quickly, especially if you don't have your graphics calculator at home. I use it when we're drawing graphs for tests and so forth. It's good free software online. Just press open graphing calculator. Okay, go to Desmos.com. Now we're told to graph f of x equals sine x. Okay, so that's the first thing that you will type in. Now, we'll start with 3f.1. And we're going to graph y equals, so I've already got that one. Now I'm going to click onto the next one, and we're going to graph y equals f of x, and then we have plus d. Okay, graph y equals f of x plus d. Slide d for different values. So I'm going to add this slider and then we're going to slide it up and down and observe what happens to the graph, okay? So when D is 0, all right, I just have the graph sine x. We will learn more about the graph of sine x in term 2. But as I increase the number, if I go 1 or if I go 2, I'm moving, the whole graph is moving up 2 units. Look, that unit has moved up to there. That one has moved up to there. It's moved up 2 spaces. Every point on the graph has moved up 2 spaces. Okay, if we slide it down, if we get negative numbers, if I go to -5, every number on the graph has moved down 5 units. Okay, so slide D for different values. What do you observe? And you can just articulate this as best as you can. It doesn't need to be precisely mathematical. You can just say, when I've graphed it, it moves the function up D units or it moves the function down D units. Okay? You'll observe similar features for the next parts of the graph, which I will float around and help you guys with on your laptops how to do it. Okay, so take you through there's the instructions there, and you're just making observations alongside to the best of your ability. When we're done, we'll come back and we'll describe it in correct mathematical notation. Okay, so let's start with that. That's our 3